right here it says state the function and its condition, which is technically the domain, all right? What function is this? What line is this? In order for you to state the line, you need to know the m and you need to know the b. So what's the m value?
2.
The m value is, how much do you rise and how much do you run? And 1/2. And ladies and gentlemen, it's always important to know that when you do slope, rise and run to the right always. Run to the right always. You always want to run in a positive direction. Yes, if you wanted to extend this line, you could go backwards and go down in this way, down in this way. But when you come up with your equation, when you come up with your slope, always go from left to right. From here to here, what are you doing? You're rising 1, running 2. So that means that the slope is 1/2. Now what's the b value? The b value is, where does it cross the y-axis? At 1. Okay, so the equation is y equals 1/2 x plus 1. But we need a condition because the whole line would usually extend this way forever and this way forever, correct? And we only have that red piece, not the blue piece. So where is this from? Let me actually do this. Look, on your piece of paper, you might, like on the test, you might want to take out a couple of pieces of paper so you could actually cover this part of it up and then cover this part of it up and say, okay, this is the only piece I want to represent. So that's between the x value of what and the x value of what? What's this x value? What's that x value? 0 and 2. So you need to make a compound inequality on your condition. You're going to say if, and to make that compound inequality, it's really easy. You just write your smaller number on the left side, which is 0, your bigger number on the right side, which is 2, and you put x right in the middle, right? And you always put the inequality symbols less than, okay? And if you have a solid one, a solid dot, you have to put the solid line underneath it, which would be right there. And that's it. We have written our piece, our function, with its condition that only gives us that red piece. Any questions? Okay, cool. Now, obviously, when we do piecewise functions, you have 3 different pieces, but right here, we're just practicing one piece at a time. That way, when we get to the 3, you'll understand it better. Let's take a look at another one. How about this guy? A lot of people get confused with this guy. State the function and its condition. All right, so what would the equation be? What is the slope right here? Marisol, could you tell me the slope? Anybody tell me the slope? 1/2? Or is it negative 1/2? Positive 1/2, right? Okay, you have to look at it from left to right, and so many people look at it backwards just because the arrow is pointing that way. Remember, you're looking at a whole line, but they're only showing a piece of it. So the slope is up 1/2, and it continues up 1/2. So I want to put a dot right here to extend it, and I continue to go up 1/2 if I want to extend it as far as I want. This is my line. However, we know we're going to have to erase that piece of the line, right? But I extended it so you could see the b value. What's the b value right there? The b value is -1. The m value we said was up 1/2. So now I know my m and my b. I could erase this other part. I could write my function y equals 1/2 x minus 1. And the condition is if. Now, is this piece between 2 x values, or is it to the left of an x value or to the right of a left of an x value? So what is this? What is the condition here? X is what? Anybody? Is less than -2. If x is less than -2, that's your condition. Again, if you were to take a piece of paper and just cover up this piece, because your line really does go this way forever, right? But you don't want to show that piece. You're only showing this piece over here. So you're only showing with regards to the x's. This is the x value of -2, and you're showing to the left, which would mean x is less than -2. Why is it not less than or equal to? Because that's an open dot, not a solid dot. Does that make sense? Okay. Another tricky one. So we're going to call on somebody at random to actually write down the y equals mx plus b equation, and then we'll call somebody else at random to write down the condition of that line. Excellent. Thank you very much, Melissa. That is absolutely correct, right? The only slight detail that you would need if you're writing this out is the if part, right? I've seen other books that instead of if, they write the word when. So it's this function when your x's are between 2 and 4. Now notice both of these are open dots. That's why both of these do not have the solid line underneath it. All right. So right now, I asked the class to discuss this question. What's the domain? What's the range? And this is what they're saying. So keep going. Wait, what were you saying? Okay, they're afraid of the microphone. What are you saying, Grant?
Y is either, I think it's y is greater than 0. Y is greater than or equal to 0.
Right, greater than or equal to 0. Now, would that be the domain or the range?
That would be the range.
All right, it's looking good. Let me get somebody to write the answer. So right here, it is true that the domain is x equals all real numbers. And the reason for that is, when you look at the whole thing, do any of these pieces go to the left forever? Yes, the blue one goes to the left forever, right? It'll have x values that are any negative number this way, and it'll have x values that are any positive number this way. All right, so it does continue to the left forever and to the right forever. So it really does have every single value for x. You could come up with any coordinate you want that has any x value, and it'll be on this graph. Look, watch, give me a number. X equals what? X equals 5. So if I go to x equals 5, is there a coordinate on this piecewise function? Yeah, it would be right there. 5, 1 would be the actual location of the coordinate, right? So this really does have all real numbers. So domain, x equals all real numbers. Why? Because it goes to the left forever, goes to the right forever, and there are no gaps. What do I mean by that? If this would have been an open dot, and that's an open dot, we'd have a gap at -1. So we would have to also state, but x cannot be -1. But there are no gaps, right? Right here, solid, this one's open, there are no gaps. So x equals all real numbers. Now the more entertaining part, the range. The range are your y values. So is this y equals all real numbers? No. What is the range here? Anybody? Y is less than 4. Y is greater than or equal to 0. Y is what, Lexi?
It's greater than or equal to 0 and then less than or equal to 4.
Okay, so you're saying y is greater than or equal to 0, but less than or equal to 4? So you want to write it as a compound inequality and say between 0 and 4?
Yeah, it's between 0.
Okay, so Lexi is saying that y is in the middle, 0 and 4, and we have these inequality symbols, and I'm assuming this one's going to be solid at 0, and it's also going to be solid at 4. But what do we think of that? That's saying that the entire function is between here, and it does not exist anywhere above this, and it does not exist anywhere below this. The line on the left, the blue line, really does go all the way up past the value of 4, so it cannot be a compound inequality. Does that make sense, Lexi?
Yeah.
Are you sure?
Yeah.
All right, so this cannot happen. Let's erase it. So again, this whole piecewise function, does it exist at -1? No. At -2? No. It starts existing here at the y value of what? 0. And it exists at 1, at 2, at 3, at 4. And it doesn't stop at 4. It exists up here. You just don't see it. It's up here with the blue line. And it continues to go up forever. So we're going to say y is greater than or equal to 0, and that's it. Okay, good. Now this is an interesting one, especially because some people, I've never shown you, I should have shown you a piecewise function where they're actually connected, right? So this has an open dot, this has a solid dot on this green one. This blue one has an open dot at the same location. And it's okay if they're connected like that. It is possible, just to let you know, okay? But right here, I don't even want to talk about the actual piecewise function. Again, I just want to say the domain and the range. Talk to a partner. So let's talk domain and range. What is the domain? Whoops. What is the domain of this guy? The domain is, does it go to the left forever? Does it go to the right forever? Yes, so we're going to say x equals all real numbers, but It's my butt right there. But what? X cannot be a certain value. Cannot be negative 2. See, it has an open dot here and an open dot there. So yeah, you do have all values. There's an x value of 0, x value of 1, x value of 2. There's an x value of half. It's right there. There's an x value of negative half. It's right there. But there is no x value of negative 2. So it's x equals all real numbers. But x cannot equal negative 2. Does that make sense? Now, those are rare cases, but they do happen. Sometimes there's gaps, and you have to state those gaps. How about the range? The range are your y values. And Jennifer, what would you say? Y is less than or equal to 2. Perfect. When you're thinking about the y number line, the highest point of this piecewise function, the highest point is here. There aren't nothing that's pointing up, nothing pointing up. This is the absolute highest point. So your whole function has to be less than this y value of 2. It is a solid dot there, so it's or equal to. Perfect.